Hello everybody, this is Dr. Hussein in math number 2, the second part of math in level 1, where you already study math 1000 mathematical foundation, and this is math number 2 extension for the previous one, which is math 1100, called calculus and linear algebra. We're going to discuss here in this course 3 topics: vector calculus and matrices and differential equations. In each there are subsections to be discussed. Our learning outcome, we have 4 learning outcomes to determine the vector, differential and integral calculus, to identify and calculate the matrices operation and use them to solve systems of linear equations, and calculate eigenvalues and eigenvector of matrices. Definitely we will use them in some applications. And finally is to solve first and second order differential equations. Now we usually, as you know, for each course you have course learning outcome, you have program learning outcome. They are linked to each other through this this matrix, or this, let me say, table. Okay, usually I advise to for the material for this course is to follow these 2 references. They are available on some website, they offer them for free, and they are available in Sohar University Library. Advanced Engineering Mathematics by Crisis and by Zell and others. Now module 1 is about vector calculus and matrices. Okay, I will start with vector calculus. Just to remind you, you already studied vectors in scalars and vectors in semester 1, okay, mathematical foundation, so you know the principles and the ideas there. Now what we are going to do is we are going to link the vectors with differentiation and integration in this part. So the first this week we will talk about vector calculus operations, the gradients of scalar functions, directional derivatives, divergence of vectors. And I would like to clarify here how we will go through this semester. Through the calculus and the algebra, we are going to talk about the theory in this session. Usually, I give examples and I give you exercise to follow the examples. Okay, I change either a function, the variables, the numbers, and you need to follow. So you need to know the procedures, how you follow them, and then you will get the experience, which is important. Okay, definitely in tutorial you have more problems, in the references and textbooks you have more problems to solve. Let me start with revision, just to remind you, to refresh your memory about vectors. We classify numbers or amounts into scalar and vector. Scalar are a quantity without magnitude, with no direction. Example, mass, volume, distance. While vector have a direction. As example, acceleration, velocity. Usually, let me bring my pen here, okay. Usually, a vector is represented by a row in this way, okay, having tail and nose, okay. As example, this OA, it's written this way, OA, and there is, you see, a row above, so to say that this is vector. Sometimes it's written as in this way, okay. Sometimes it's written with line above. Sometimes it's written with you can see different way they represent in textbooks. Sometimes written as a ray in this way, okay, or in this way, and sometimes it's written as a bold. As example, a bold in this way, to say that this is vector. Okay. Each vector has a length or magnitude, represented in this way. As example, magnitude. Now, if we talk about 2-dimension or 3-dimension, for 3-dimension also we can say that we have unit vectors for I, j, k. As you can see here, 90 degree is the difference between them. They are on x, y, z respectively. As you can see, I here, j here, k here, and they can be represented by right hand set or right hand rule. You can see that they are perpendicular on each other. Okay, we will see. You remember you study already product, different type of products. One of the product, which is a cross product, as you can see, is presented in this way: A cross B, to find the vector perpendicular on the plane of A and B. Okay, represented by right hand rule, as you can see here in this figure. It's used for many applications in industry. This is the screw, one of the applications. Okay, it's used in design the screw. Now if we have any vector p as example, which have x, y, z, okay, and represented this way, xi plus yj plus zk, okay, so we have three-dimensional vector. Now its magnitude will be x square plus y square plus z square under square root. You can see here, this is the magnitude. Now if we have two vectors a and b represented as you can see here, a and b, and we want to add or subtract them, we go to the I, j, k items and add them or subtract them. Okay, as you can see here, a1 b1, a2 b2, a3 b3. Still we will come up with the vector. Adding vectors or subtracting vector will give you vector. And we can say a equal b only and only if I, j, k elements are the same. As example, a1 should be equal to b1, a2 equal to b2, a3 equal to b3. Otherwise they are not equal. They're supposed to have equal values for I, j, k items respectively. Okay, what if we multiply scalar value by vector? We have vector b and we want to multiply it by alpha. Then we need to multiply alpha by all elements, I, j, k elements, okay, as you can see here in this equation. Now here just a few exercises to refresh your memory and to remind you. I advise to solve them at home. Now for vector product, you already study two types of products, scalar product or vector product. Scalar we call it dot product, and vector product cross product. For dot product, you have two vectors, a dot, you see here the circle, the point, b. Okay, now dot product will produce a scalar value. For that we call it scalar product. Okay, and what we do here, we multiply I items for both vectors plus b, j items for both, k items for both vectors, and this way I, j, k will disappear. Okay, we have only you see here only numbers, scalar, so it gives final scalar vector. Another way to find the product, dot product, is by multiplying the magnitude of the first and the second vector by angle theta, which is the angle between a and b. For cross product, in this way, a cross b, we will make a like a determinant, okay, x I, j, k in this way, and then we add a elements here and b elements here, right? Now let me change the color. If we want to find I element, as you can see here, what we will do, we will hide these row and columns which is part of I, and then we multiply a2 by b3 minus a3 by b2, and we apply it for jk again, repeat it again. Okay, but have a look here, what we have I, j, k, so cross product will produce vector, so at the end you have vector. Now after this revision, let me start with our topic, which is the vector calculus. I will start from del operator, which is represented by this triangle, upside down triangle. Okay, del operator, as you can see here, partial, it's represented by partial over partial xi, partial over partial yj, partial over partial zk. Oh, del is a vector. Yes, is a vector. It's contain partial fraction, partial differentiation. Okay, just a minute. What is the difference between differentiation and partial differentiation? The normal differentiation, we differentiate with respect to one variable. But partial derivative, when we have the function which is function of more than one variable, as example, z is function of x and y, right? So now we have two variables, x and y. So when we differentiate here, as example, partial over partial x, it means we only differentiate with respect to x. All other variables to be keep as a constant. Now, okay, this is del operator. Where we are going to use it? We are going to use it in a gradient of a scalar function, which have many applications, as I will explain in the next example. Now